Okay, let's just jump right in. We all think of AI as being incredibly smart, right? But what happens when you ask it to plan ahead, to solve a really complex long-term problem? Well, it turns out that's a whole different ballgame. It's incredibly hard. So today, we're going to look at a brand new method that helps AI planners get a much better, well, grasp on reality. So you look at a puzzle like this and you have to wonder, how does an AI even begin to figure it out? I mean, how does it learn to manipulate objects, navigate its world, and actually reach a goal, especially when it requires a long sequence of super precise actions? That's really the core question we're unpacking. And to get that answer, we first have to understand how these AIs actually see the world in the first place. They do it with something called a world model. You can basically think of it as a form of digital imagination. A great way to think about it is like your GPS. It doesn't just show you a static map, right? It's actively simulating traffic, it knows about road closures, it's trying out different paths to predict the absolute fastest way to get you there. An AI's world's model does the exact same thing, but for actions. It runs thousands of tiny simulations to imagine what's going to happen if it moves left or right or pushes that object. All right, so if AI can imagine the future, you think planning would be easy, right? So what's the holdup? Why is planning ahead still such a huge hurdle? Well, here's the core of the problem. The best plan, it turns out, is often not the most obvious one. And that's a really tricky concept because we're always taught, the shortest path from A to B is a straight line. But in these really complex problems, taking that direct, obvious next step, that can actually be a trap. It can literally stop you from ever getting to the finish line. And check this out. This graph shows the data from a plan that actually worked. And look at the very beginning of the plot. The distance to the goal goes up. It's moving away from the solution. The AI had to take a step backward to eventually move forward. Now, any simple, greedy planner that just takes the most obvious step would get stuck right there and just fail. So this whole mess basically creates what we can think of as two big villains in the world of AI planning. First, you've got hidden valleys. These are solutions that look really good at first, but are actually dead ends. And second, you've got unreliable directions, which is when the AI's own map of the world is just plain wrong and can't be trusted. This visual right here just nails that hidden valley problem. Imagine the AI is a hiker, okay? And its job is to find the absolute highest peak in the mountain range. That's the best possible solution. The landscape on the right is the kind of map that older methods have to deal with. It's super bumpy, full of little hills and valleys. So the AI can climb up one of these small hills, think, hey, I made it, I'm at the top, and just get stuck there, completely missing the real summit that's just a little further away. And that second villain, unreliable directions, is just as sneaky. See, the AI's internal model, its map of the world, it's not perfect. It can have tiny glitches, almost like bugs in a video game. A really aggressive planner can actually learn to exploit these glitches inside its own simulation to solve the puzzle. But of course, those tricks don't work in the real world. It's like the map is actively lying to the AI. So, how do you fight these villains? How do you teach an AI to sidestep those hidden valleys and ignore the bad directions? Well, that's where this new approach comes into play. It's called GRASP. Now, that stands for Gradient Relaxed Stochastic Planner, which, yeah, it's a mouthful. But the core idea is actually pretty straightforward. It's a brand new toolkit designed to help the AI navigate its own super complex and, let's face it, sometimes totally misleading internal map. Okay, so how does it actually work? How does GRASP pull this off? Well, it uses three really clever tricks that, when you put them together, completely change the game for how an AI plans. Let's dig in. The absolute biggest shift is going from what's called serial planning to parallel planning. Think of it like this. The old way is like a road trip where you only get your directions one turn at a time. Turn left here, now go straight for a mile. If you miss just one of those early turns, the rest of your instructions are totally useless, right? GRASP parallel planning is like looking at the entire map before you even leave the driveway. You see the whole route from start to finish all at once, and you optimize the entire journey together. And you can see that difference right here. That top part, that's the old way, the serial plan. It's like a fragile chain. If even one of those links breaks, the whole thing just falls apart. But now, look at the bottom. That's GRASP's parallel approach. Every single step is being considered at the exact same time. The planner can see how a tiny change way back at step 3 is going to affect what happens at step 30.
This makes the whole plan way more flexible, way more robust. It's not going to collapse just because of one little mistake early on.
So what about those other two tricks? Well, they go right after the villains we talked about. First, to beat the hidden valleys, it adds a little bit of randomness, a bit of noise into its search. This lets the AI kind of hop out of a valley it gets stuck in and go explore a totally different part of the map. And second, to fight the unreliable directions, it relaxes the rules. It basically learns to ignore some of the shakiest directions from its own model so it doesn't end up tricking itself. Okay, so the theory is awesome, right? A parallel planner that's smart enough to not get stuck and not fool itself. But does it actually work in practice? Let's take a look at the results. And wow, this image really says it all. Remember that super bumpy, treacherous landscape our little AI hiker had to climb on the right? That was the old way. Now look at the left. That's the same problem, but it's the landscape Grasp creates. It's smooth, it's simple, it basically turns a hardcore mountain climb into a gentle walk up a hill. Finding the best solution becomes so much easier. So what does that smoother path actually translate to in performance? For starters, you get a 10% boost in the actual success rate. And for these really tough, long-term planning tasks, a 10% jump in reliability that's huge. That's a massive improvement. But it's not just about being more successful, it's also way more efficient. It gets these better results using less than half the computation time. Think about that. It's not just smarter, it's also way faster. And in the world of AI, getting better results while using less compute, that is the holy grail. That's the ultimate goal. So what's the big takeaway here? What we're seeing is an AI that's learning to think ahead in a way that's much more robust, much more efficient. It's almost like a form of common sense. By giving it a better map and a better compass to navigate its own imagination, we're unlocking its ability to tackle problems that, honestly, we thought were just too hard before. And that leaves us with the big question, right? If AI can get a better grasp on planning, what kind of complex real-world problems are next?